Hello everyone, so we're back doing another experiment. This one is investigating chemical reactions. You will need your lab coat or apron, pair of latex gloves, and don't forget your eye goggles. Now I'm going to be kind of out of the screenshot more because I want to focus on the experiment itself. So just make sure you keep your eyewear on, latex gloves, and your science apron or apron of science. Um, so now that we have our safety equipment ready, a few things I want to point out before we get started is I did some prep work before shooting the video. And one of those things was creating this little stopper. And it's basically a pipette that I've cut off the end and the bulb, and I've inserted it through the stopper and added the this hose at the end of it. And we'll be using this to plug up one of our test tubes. And a few other things that I've also done was I just added some rubber bands to our test tube to keep them from rolling off the table when we're not using them. So now that we're all set, let's go ahead and move on to activity number one. Now for the first activity, we'll be using 50 millimeters of white vinegar into the graduated cylinder. So let's whip out the 50 milliliter graduated cylinder, and that's the one we'll be using to measure out the vinegar. Now that we have our 50 millimeters of the white vinegar, let's go ahead and place our thermometer in the vinegar. We're going to measure the room temperature. I'm assuming it's going to be 22 degrees Celsius since the vinegar has been sitting on a shelf in the room, and the room is 22 degrees Celsius. But for the purposes of this experiment, we're going to go ahead and follow every step. So we're going to find out what the temperature of the vinegar is, and we're going to record it in the data table. All right, I believe that's long enough. All right, we're actually at 23 degrees Celsius. So you see, I'm kind of glad I did that. Otherwise, we would have been 1 degree off. All right, we're going to go and take the thermometer out, dry it. And we're going to set it aside for future use. Now we're going to take the steel wool. And what we're going to do is we're going to go ahead and tear off a chunk of this. And if I can find my scissors, oh, here they are. Would you pass me a paper towel or something? Alright guys, well these scissors kind of didn't work out, so hang on tight while I grab myself another pair that will actually cut. Alright guys, I grabbed myself another pair of scissors. Hopefully this one gets the job done. Alright, we're going to use one, let's go ahead and use this piece. We're going to use one of the steel wool pads, the other one we're going to go ahead and set it aside. And again, we're probably going to be using this in future experiments. Alright, so we're going to set this aside. We're going to place this on one of those weighing cups just so I don't get any steel wool residue all over the place. Okay, now that we cut one of those in half, we're going to assume that the steel wool remains at room temperature, which again, it's 22 degrees Celsius. Make sure you record that as well. Alright, now we're going to take the steel wool piece that we did cut, and we're going to fully submerge this into the vinegar. All right, now that I think I think 2 minutes have passed that the steel wool has been fully submerged in the vinegar. We're going to go ahead and remove the steel wool from the cup and carefully squeeze the excess vinegar back into the cup. Alright, now we're also going to need the other piece of steel wool that we used before, so I'm going to grab that. I'm also going to need a timer, so I'm going to ask my assistant to work the timer. Okay, now we're going to take our thermometer and we're going to wrap the steel wool around the thermometer. And make sure you want to do this around the bulb of the thermometer. It's kind of pointless to wrap it on the other end. And we're going to secure it with a rubber band. Okay, now that we've secured the thermometer, we're going to go ahead and start the timer. Start the timer. Start the timer. Okay. Now we're going to observe the synthesis reaction for 10 minutes, and then we're going to record the temperature of the steel wool at around 5 to 10 minutes after the start of the synthesis reaction, and then we're going to record our data into the data table. So I'm going to go ahead and pause the video and then come back at the 5-minute mark, and then I'm going to come back at the 10-minute mark. Alright, so now we're back and we're right at the 5-minute mark. We're going to take a look at the thermometer and record the temperature. It appears to be 32 degrees. So we're going to record that. And then we're going to come back right at the 10-minute mark. Alright, so now we're back. As we approach our 10-minute mark, we're actually 3 minutes away. So what we've noticed is that the temperature has dropped down to 30 degrees Celsius from our initial start of 23 degrees Celsius at room temperature. When we first brought the thermometer out of the vinegar, we were at 35 degrees Celsius. At the 5-minute mark, we were at 32 degrees Celsius. Now we're at 30 degrees Celsius. So it looks like the steel wool has cooled down. And I don't know if you can see it in the video or not, but the steel wool that was placed in the vinegar does appear to have rusted a bit. It's almost a little reddish, brownish in color, and a little darker than the shinier, newer steel wool that was not placed in the vinegar. So now that this concludes the activity number one, we're going to go ahead and wash everything up. We do want to discard the steel wool, the rubber band, and the gloves that I was using for this activity, as they're contaminated with the elements that we used in this activity. We'll be back for activity number two, and after we clean up. Okay, so now we're back for activity number two. For this activity, we're going to need our hydrogen peroxide solution. We're going to measure out, using our graduated cylinder, 10 milliliters of the stuff. And we're going to place it in the large test tube, which I have here. And we're going to place the test tube inside the 200 milliliter beaker to hold it upright. All right, now I've employed the use of one of those pipettes to measure out exactly 10 milliliters of the hydrogen peroxide. Let's go ahead and dump the contents into the glass test tube. Okay, we'll place the test tube inside the beaker to hold it upright. Now we're going to take our mini spoon, which is this here, and we're going to measure out 2 level teaspoons of the dry yeast. And again, I do say level teaspoons. That didn't work too well. Alright, now when you place the yeast inside the test tube, you want to observe the decomposition reaction for at least 1 minute, so make sure you have your timer ready. And then at the end of the 1 minute, we're going to record our observations and, of course, obviously record that in the data table 1 and also photograph it. So here goes 1. And here goes 2. Make sure you go ahead and start your timer. Now we're approaching our 1 minute mark. Let's go ahead and take a look at it and record what we see. As I noticed, there seems to be some sort of a top layer where the yeast collected, and a little bottom layer of this bubbly fizzling going on. So let's record that, and then we're going to give it a gentle swirl. And we're going to let it sit for another minute. All right. Now we'll come back to our test tube, and let's go ahead and take a picture to document our result. Okay, now that we've gone this far, we want to go ahead and predict the results of inserting a glowing splint into the large test tube, and also inserting a flaming splint into the large test tube. So I'm going to go grab a flaming splint, and I'll be back in just a sec. Alright guys, now that we have a glowing splint, I'm going to go ahead and insert the glowing splint into the test tube. And I predict it's probably gonna create a flame inside the test tube. Yep, and as I predicted, it didn't cause a flame, but immediately after I inserted the test tube, the glowing splint glowed a little brighter. Now let's go ahead and try that, but with a burning splint, and see what happens. Again, I predict it's probably gonna burn out. And contrary to what I predicted, it looks like it actually burned brighter. And we're going to try that again. I don't know if you guys can see that. Well, it looks like all the gas inside the test tube burned out. Alright, so we'll go ahead and turn that off. We're going to also turn off our torch. Set that off to the side. Okay, so just to conclude this experiment, um, when I placed the glowing splint into the large test tube, uh, immediately it burned a little. It actually glowed a little brighter. When I inserted the flaming splint into the test tube, the flame grew in size. It was insignificant, but it did grow just a little bit. After all the gas burned inside the test tube, it started burning out. So my predictions were wrong. It appears it let off oxygen, which, as we know, oxygen causes the combustion to increase. So that's going to wrap up activity number 2. We'll be back for activity number 3. Here we are with activity number 3. For this one, we're going to use the strip of magnesium that we have previously pre-cut. If I can get it out. Okay, I'm trying to think. Alright guys, seeing how the test tube that I had placed my pre-cut strip of magnesium was contaminated with water, so we're gonna go ahead and discard of this strip. We're gonna clean out this test tube and we're gonna cut off another piece. Well, we're back for activity number 3. In this activity, we're going to be looking at single replacement reactions. So what we'll need is our smaller beaker, our 250 milliliter beaker filled to the top with water. And this is purified water. 0 TDS, and I keep mentioning that in each one of my videos because I'm pretty proud of the water filter that I purchased. So this is again 0 TDS water. Your bottled water usually contains some impurities. They've added a few carbon for taste and inserted some electrolytes into the water, so that bottled water doesn't read 0 TDS, but this purified water that I'm using for these experiments does. So we'll get on with the experiment. You're going to take the magnesium strip that you previously cut, and you're going to insert it in the hole of the tapered side of the small rubber stopper. You may have to bend it a bit. There we are. As you can see there. Now we'll be using the smaller 10 milliliter graduated cylinder. And we're going to measure 3 milliliters of the hydrochloric acid, and we're going to add it to the small test tube. Alright, now that we have our 3 milliliters of the hydrochloric acid, we're going to add it to the small test tube. Okay, now we're going to add 50 milliliters of water to the 50 milliliter graduated cylinder. Oh wow, I nailed it right on the spot, 50 milliliters. Now we're going to use one of our pipettes. And we're going to hold the small glass test tube containing the hydrochloric acid at a 45-degree angle. And we're going to slowly add the water to try to layer the water on top of the hydrochloric acid so as to not to mix the water with the hydrochloric acid. So you want to keep the water on top and the hydrochloric acid on the bottom. And you want to continue doing this until you're about 1 centimeter away from the top of the test tube. Okay, now we're going to hold the glass test tube over the beaker, and we're going to carefully insert the stopper fitted with the magnesium strip into the opening of the glass test tube. And when you do this, allow any overflow of water to drain into the beaker. And we're going to carefully invert the test tube and place the inverted test tube into the beaker of water, allowing it to rest in the beaker at a 45-degree angle. And we're going to go ahead and start our timer. We're going to observe this reaction for 10 minutes, and then we're going to record our observations. Alright, now that we've inverted our test tube, immediately I'm starting to see some bubbles bubbling up to the top of the test tube. And we're gonna observe this for 10 minutes. We'll be back when we near the 9-10 minute mark. Alright, I'm checking in right at the 5-minute mark. We're still noticing bubbles form inside the test tube, which has cleared out half of the water that was inside the test tube. So it's pushing it out as bubbles are forming and collection of gas towards the top of the test tube. We're going to continue monitoring this, and we'll be back at the 10-minute mark. Now we're back. 10 minutes has expired, and it appears that the contents within the test tube have stopped bubbling. So we're going to do this very carefully. I have a burning splint here off to the side.
Make sure it burns. I need to create a flame here. So pick up and make sure it creates a flame. So when we lift the test tube out of the water, the beaker containing the water, very carefully, you want to keep the test tube inverted as to keep the gases inside the test tube. All right, and very rapidly insert the burning splint into the test tube, and let's see what happens. Well, it happened very rapidly, guys, but it almost seemed to pop as I got the burning splint close to the test tube. I was trying not to burn myself, but let's see if it happens again. If I can get a flame out of the burning splint. Here we go again. I think you guys probably heard that one there. Let's see if it does it a third time. Nope, looks like it's all out. All right, now we're gonna go ahead and clean up. This would conclude this activity. Looks like I burned the tip of the test tube, so we're gonna clean out the beaker and the test tube and any other tools that we use for this activity. And then we're gonna be back for activity number 4. Now, don't forget, you do wanna record your observations before you clean up. That way it's still fresh, and then we'll be back. Here we are with activity number 4. For this activity, you're going to need the 50 milliliters of vinegar that was saved from activity 1. Hopefully you didn't throw it away. I did fail to mention to keep the vinegar. Now it does have some particles from the steel wool that we inserted earlier. Per our lab, it instructed us to use the exact same cup with the vinegar, so I guess we're going to leave those steel wool particles in there. Now you're going to use your scale for this one, so go ahead and turn on your scale. We're going to need a weighing boat. Place it on the scale and zero it out. Now we're going to need our baking soda. I got baking soda. So we're going to need 10 grams of this stuff. And if you caught that, I was making a reference to a pretty catchy song that just recently came out. Now I need something to fish this stuff out. Alright, so I have a spoon. I have my baking soda. And let's see if I can nail it right at 10 grams. Yep, there we are. I nailed it. 10 grams. Oh, looks like it went over a little bit. I mean, I'm going to fish some of it out. Oh, too much. All right, there we go. All right, that's 10 grams of our baking soda. candle actually. What happened to the... Alright, now I'm lighting my candle up. It actually burned out. We're going to need our burning splint and the glowing splint again. So we're going to set that off so it could burn a bit. Yeah, caught fire quick. Alright, so I have our baking soda ready. We're going to pour it over into the cup containing the vinegar, and we're going to cover it loosely with a small piece of paper towel to retain more of the gas in the cup. And we're going to go ahead and start the timer. Now here we're only going to time it for 1 minute. Then we're going to photograph our observations, and then once we photograph the observations, we're going to gently swirl the contents of the cup to complete the reaction, and then remove the small piece of paper towel covering the top of the cup and observe the contents again. Looks like we had some overflow there. Alright guys, now that it's been 1 minute, we're going to go ahead and record our observations and give the cup a nice swirl. And we're going to insert first a glowing splint, and we're going to record our observations. Alright, that seems to be glowing. And it immediately burned out. Now we're going to try this again with a flaming splint, and again immediately it burned out. I'm going to try to point this towards the camera to see if we can catch it. You see, it started burning out. Let me give this another swirl so we can produce some more gas. If I can get the splint lit up again. Here we are. Give it a swirl. Oh, this time the reaction has stopped. We're going to put out our splint, and we're going to record our data. Go ahead and throw this away. And we're going to keep this cup of vinegar and baking soda for a later activity, so I'm going to set that off to the side. And now that we're done with this activity, we're going to go back and record our data, and then we'll be back for the next one. Alright everyone, we're back for activity number 5, the combustion reaction. For this activity, we're going to need our burning candle, which I already have here. Now, again, we're also going to use the vinegar and baking soda that we had from our previous activity, and we're going to need an additional 50 milliliters of vinegar, which I've already pre-measured here to save us some time. Now we're going to use our small test tube, and we're going to hold it over in an inverted position, so it means the opening downward. We're going to hold this over the candle wick for 30 seconds. Now I'm going to employ the use of our forceps just because I don't want to burn myself. We're going to hold this
just slightly over the flame to collect gases. Now I'm going to stop talking so I can stop blowing the flame away. All right, now that we've held the test tube over the flame for 30 seconds, we're going to go ahead and record what we see, which isn't much. The test tube to me still appears clear. Now there may be a possibility that there is a gas inside the test tube, but it's not a color that's visible to my eyes or anyone else's. So we're going to go ahead and photograph the test tube using the help of my assistant. Okay, and we're going to set this off to the side. Being careful because that test tube may be hot. Now we're going to use the cup containing the vinegar and the baking soda from activity 4. We're going to add an additional 50 milliliters of vinegar to it. And as you can tell, I overflowed the cup. Luckily, I got some towels handy. Now we're going to take the cup and invert it as to pour the gases over the candle. As you can see, the candle is doing some flickering. Okay. Now the candle did flicker a bit. It didn't put out the flame, but it did flicker a bit. Now we're going to go ahead and record our observations in data table 1, and go ahead and extinguish our candle. All right, here we are with activity number 6. For this one, make sure you have your rubber stopper with the pipette and the hose attached to it. We're going to be using that. Also, our large test tube, and we're going to need another 5 grams of the baking soda. So I've already pre-weighed 5 grams. Let's just confirm that this is indeed 5 grams of the baking soda. And of course it is. So we'll go ahead and turn off our stove, set that off to the side. And we're going to be careful to add this baking soda to the large test tube. All right, now that we've added
our 5 grams of baking soda to the large test tube. We're going to go ahead and place the test tube inside the 200 milliliter beaker so as to hold it upright. And we're going to measure 10 milliliters of the white vinegar using the graduated cylinder. Alright, now we're going to pour the vinegar into one of our plastic test tubes. Okay, now we're going to go ahead and set that here for just a second as we prepare. And we're going to use the small glass test tube, and we're going to fill it up with lime water, at least approximately halfway full. Alright, now we're going to place the test tube containing the lime water in our test tube rack. Okay, now we're going to take our smaller test tube and we're going to place it upright into the larger test tube containing the baking soda, and we're going to top it off with our rubber stopper. Alright, hang on guys, seeing how there's too much excess pipe, I'm going to cut off just a little piece and insert this back in. Okay, now that it's in there firmly, we're going to place the other end of this hose in the test tube containing the lime water. And we're going to make sure it stays fully submerged. Alright, now we're going to get a large test tube and we're going to tilt it to let some of that vinegar react with the baking soda. You'll start seeing our lime water bubble. Now we don't want to let the vinegar react with the baking soda all at once, so we're gonna do this slowly. Once it stops bubbling, go ahead and pour out some of the vinegar so we can start the reaction up again. All right, now once the cat is out of the bag, and what I mean by that, once all the vinegar is out of the smaller test tube and reacting with the baking soda, we can go ahead and stop the bubbling, and we're going to let the lime water sit for about 5 minutes. Now here I'm just moving that test tube to allow some of the vinegar to react with the baking soda. All right, once it stops bubbling, go ahead and take the hose out of the lime water. We're going to set that off to the side. Where's our beaker? Okay, now let's observe the lime water. It still looks the same to me. It looks clear. I mean, nothing in particular that I noticed different from the lime water before. So we're going to place that back on the test tube rack. We're going to observe it for 5 minutes, and then we'll be back after the expiration of 5 minutes. We're going to record any additional observations that we see with the lime water. All right, now that it's right at the 5 minute mark, we're going to take our lime water and observe it. I still see no physical change in the lime water, so I'm not quite sure what we were looking for. Still, it appears clear in color. We're going to go ahead and snap a photo of this just to document. But again, I'm not quite sure what we were looking for. All right, thank you, assistant. All right, we're going to set that off to the side and move on to activity number 7, which is the combustion reaction. And for this, we're going to need a plate just to protect our countertop. We're going to need our candle. Go ahead and light it. And we'll be using the steel wool that we had left over from our previous activity. Using our forceps, I've already pulled apart some of the steel wool, and I'm going to hold this over the flame to see if I can catch any of this on fire. Yeah, attempt to ignite the steel wool. I don't know if you can see there, but steel wool catches on fire and some of the fibers are falling down into the candle. Now, as I'm burning the steel wool, I'm noticing that the flame travels through the steel wool as some of the steel pieces fall. This is quite interesting. All right, we're going to go ahead and wrap this up. I'm going to record what we observed here. Looks like I burned the forceps a bit. Looks like they melted. And that would conclude this experiment, investigating chemical reactions. So we'll be doing our next clip on balancing chemical equations. So stay tuned for that.